1, which is an introduction to statistics, and it's a lot of terminology that we need to learn. The first thing we need to learn about is data. Data are the observations that are being collected. They could be measurements, they could be gender, they could be religion, or they could be survey responses. Statistics is a collection of different methods for planning the experiment, for obtaining this data, then organizing the data, summarizing the data, analyzing the data, then interpreting this data, presenting the data, and then drawing some kind of conclusions based on the data. There are two main types of statistics. The first one is known as descriptive statistics, and we'll be talking about descriptive statistics in Unit 1. And then inferential statistics, which uses the sample data and descriptive statistics to draw some kind of conclusion about a population. And we won't be seeing inferential statistics until we hit Chapter 7. Terms we all need to be on the same track on is the main definitions of the difference of what a population versus a sample. Now, the population is the complete collection of all the elements being studied. It's all of the outcomes or all of the people, all of the measurements. So the population could be, it's all college students in the United States. A census is a collection of data from every member of a population. This is usually very hard to do. So what we usually do is take a sample, which is just a subset of the population. So if our population is all college students in the US, then our sample might be a randomly selected sample of 1,000 college students that are in the US. Once we have our population, then we're going to take some values, and some of these values we're going to be using. So a parameter is a numerical description of the population. For example, it's the mean cholesterol reading of all men between 50 and 75 years. Remember, it's the number, it's the average cholesterol of all men. But the statistic is the numerical description from the sample. So it would be the average cholesterol reading of 500 men randomly selected between 50 and 75 years that are in my sample. Notice parameter starts with P and so does population. Statistics starts with S and so does sample. A parameter goes with a population. A statistic goes with a sample. To make sure we understand are the types of data. The first type we're going to talk about is quantitative data. This is data that consists of numbers which represent counts or measurements. It could be a height, it could be the number of students taking a class. It's a number. Number of left-handed people. Qualitative data is data that can be separated into different categories. Sometimes qualitative data is also known as categorical data, and they're distinguished by some non-numeric characteristics, such as religion would be qualitative. It's just a category. Now be careful, because there's a few categorical data sets that are numbers but are not truly numeric. For example, the area code for your telephone number is not truly a number. It's a category that lists a place where you live. Also, your social security number is a number, but it's not quantitative. It's not a real number. It's really just a category. It's a label that labels you. Gender of diabetic patients is quantitative. True or false? You're right, that's false. Gender is a category or qualitative. So types of quantitative data, there's several types of quantitative data. The first one is discrete data, and discrete are countable numbers. So those are things like if we're looking for the number of students who are taking the class. There could be 0 students taking the class or 1 student, but there's no such thing as 1.25 students taking a class. So discrete are countable numbers. The number of cups of coffee sold. Continuous are values that can be taken on any value on an interval, and these are measurements. So for example, suppose I have discrete would be the number of cups of coffee that I sold, but continuous data would be if I was measuring the gallons of coffee sold. You measure gallons, you count the number of cups. If you're counting them, it's discrete. If you're measuring it, it's continuous. The amount of rain is discrete? Yes or no? You're right, no. Discrete is the amount of rain is measured, thus it's continuous. All right, the number of days with rain in a month. Are you counting that or are you measuring that? If you're counting it, it's discrete. If you're measuring the number of days, then it is continuous. So what do you think? Yes, the number of days, you count the number of days, which makes it a discrete piece of data. There are different levels of measurements of data. The first one we're going to look at is nominal. Nominal are data that are just names or labels, like gender or religion. They cannot be ordered. It's just categories, just labels. Ordinal data are just labels also, but they're labels that have a meaningful order, such as but the differences are meaningless. For example, if I'm looking at TV ratings, the amount of violence between G, PG, PG-13, R, NC-17, and X. There's a meaningful order there. There is more sex and violence as I move up those ratings, but the amount of the additional amount of sex and violence between G and PG is not the exact same amount of sex and violence increased between PG and PG-13 or PG-13 and R. So the differences between them are meaningless, but there is a meaningful ordering to them. Look at interval. Now interval, the differences between the values is meaningful, but the data does not have a real zero. In other words, zero does not mean none. The classic example for interval data is temperature. 0 degrees does not mean there is no temperature outside. The other type is ratio, and with ratio it's the same thing. It's numeric just like interval, but in this case 0 does mean none. In other words, if there was 0 rainfall, then there was no rainfall. In designing experiments, you can have a voluntary response sample. Look at the little frowny face. That's not a really good way to collect a sample, because what you're looking at there is people who volunteer to join your sample are people who are either truly passionate about something, either for or against, or people who are just completely bored, but you leave out a large chunk of the population with a voluntary response sample. So, an observational study is one in which we observe and measure characteristics, but we do not mess with the subject at all. When Jane Goodall studied the gorillas in the wild, she was doing an observational study. She did not throw rocks at the gorillas to see how they would respond. She just got up in a tree blind and watched them, observed them. In an experiment, though, you do apply some kind of treatment and then observe its effect on the subject. On with terms, a clinical trial. Well, a clinical trial is one of the best, well-planned experiments possible. You usually have at least 2 groups, a treatment group and a control group. And when you're dealing with a clinical trial, you would need to consider confounding. Confounding variables are variables that are getting mixed in, and it's difficult to tell whether the confounding variable is causing the effect or the experimental unit is affecting the individual effect. We usually have to plan the experiment to avoid confounding. For example, an example of confounding. Suppose you treat diabetic patients with a new medicine, but you also put them on an exercise regime. If they seem to control their diabetes Is it because of the medicine or is it because of the exercise? Exercise would be a confounding variable because you did not take into consideration that the exercise may be having the effect. And in a clinical trial, you often have some kind of blinding. In blinding, you keep the people in the dark as to who is receiving the treatment. You do not tell your subjects whether they are part of your experimental group, your treatment group, or your control group. In a single blind test, your subjects don't know. In a double blind test, the subject doesn't know, and neither does the researcher or the doctor who is administering the treatment. They don't know either. Now, the researcher does have some records to let you know who is in the experimental group, who is in the treatment group, and who is in the control group. We do this because of the placebo effect. Some patients just get better because they think they're getting treatment. Some more terms. Now, we may block sometimes. We take a sample of in our treatment group and our control group, but then we may block certain groups because they have known similarities. Often blocking is done with gender. And then we do randomization, so we randomly select into each treatment group and into the control group. So we use random selection to assign to treatment groups. In a completely randomized design, we do a total random assignment, which means we close our eyes and we randomly, suppose we first block into, we randomize. We form our blocks. So we separate all the men and all the women. Then we randomly select men to go into the treatment group and randomly select some men to go into the control group, and we randomly select some women to go into the treatment group, and we randomly select some women to go into the control group. That's known as a randomized block design. Replication is always very important that you have the ability to repeat a study. Sample sizes need to be large enough to see the true nature of any effect. But a large sample does not necessarily mean a good sample. Samples that were not collected in an appropriate way may be useless, and just taking a larger sample, a very bad large sample, does not help you at all. Random sampling, in random sampling, each individual member has the same chance of being selected. Almost all inferential statistical procedures call for random sampling. A simple random sample means every sample of size n has the same chance of being selected. In simple random sampling, there are no blocking techniques used. Everyone stays in one big block, and you just randomly select for your treatment group and randomly select for your control group. So suppose I'm going to study one of my classes. I have 3 classes. I roll a die to select which class to study. Assuming the classes have no overlap, what type of sample is this? Now you've got to ask yourself, is there a possibility of, am I randomly selecting? So the die, yes, the die does allow for a random selection. But, so C's out. But, is there any kind of blocking or grouping going on? If there is no grouping going on, it is a simple random sample. But if there's any kind of grouping or blocking going on, it's a random sample. Because we did group first into 3 classes and then randomly selected one of the classes, right? And each person had a 1/3 chance of being chosen because there were 3 classes. The sample where students from different classes, though, is impossible, so not every sample of size n was possible. Note, most of our text requires simple random samples. There are different types of blocking with random sampling. So let's talk about the different blocking techniques or grouping techniques. For a stratified sampling design, we would divide the population into subgroups, either gender or maybe class standing, freshman, sophomore, junior, senior, and then randomly select some from every subgroup. For example, suppose we divide the population into men and women, and then randomly select 50 men, and randomly select 60 women. That's stratified because we first we blocked into groups and randomly selected some from every subgroup. sampling. We start the same way. We take our population, divide it into subgroups, and then randomly select a subgroup, and then select all of the members of the randomly selected subgroups. So for example, suppose I have 20 biostatistics classes. I randomly select 5 of them, and then all of the students in those 5 selected biostatistics classes become part of my sample. The difference between stratified and cluster. Stratified, you group and select some from every group. Cluster, you group and then you randomly select groups and all from the selected groups. Another way to do it, to block, is to do systematic sampling. In some way or another, you need to order your population, and then you randomly select a starting point and select every kth member for the sample. So suppose we have a hospital, they order all their current patients. You may be using their patient number. We randomly select the number 9, which means we're going to start with the 9th patient in the ordering, and then we choose every 9th patient after that. Of errors. Well, you have sampling error. There's always sampling error. That's the difference between the sample result and the true population result. There's nothing to be done with sampling error. There will always be some sampling error. Non-sampling error, though, we can control. That occurs when the sample data is either incorrectly collected, recorded, or incorrectly analyzed. That's an error that we can control.